Hello everyone, welcome to the another very important session in which we will be discussing some more important questions and very important concepts of quantum mechanics. I hope that important things I would like to share, like important thing which I want to share in the session is related to the unit-wise PYQ test. So these are the three unit-wise PYQ tests we are going to have for different subjects or the streams. You can see they have been mentioned here clearly. So in the learning app, you can check them out. And if you want to practice these tests, the questions in the test, then you can just join it. Okay. I hope each and everything is now clear to everyone. Now, one more thing I would like to share with you, and then we will be starting the discussion about the most important concepts, tricks, and the points which we will be covering in the session. So guys, here you can see it has clearly been shown that what is the difference between the plus and the iconic subscription. Depending on which one you find more beneficial for yourself, you can take that subscription. If you will be taking the Unacademy Plus subscription, then you will be able to get these benefits as they have been mentioned here on the screen. And if you will be taking the Iconic subscription, then you will be able to get these benefits as they have been shown here on the screen. Now, whenever you will be proceeding further to take the subscription, you can use and apply the referral code Anjali A Live. And even to grab this offer, which is just valid till today, you can use and apply the referral code Anjali A Live, and you will be able to grab this offer, as well as you will be able to get the 10% discount in the total subscription amount. One more thing, in upcoming days, even many new courses by the top educators will be starting on Unacademy. So if you don't want to miss these courses and the classes, then you can take the subscription and start your preparation under the guidance of top educators. Now let me just quickly check out that whether everything is working properly or not, because earlier I was not able to check it. So let me just confirm it once, and then we will be continuing the discussion. Yeah, everything is all right. Clear. Even in the comment section, guys, you can mention if you will have any doubt anywhere. So today's session is about the quantum mechanics. Now we will be talking about the most important concepts, most important points of quantum mechanics, which you need to cover up, and you can't miss these points. So what are these topics? First of all, let's talk about that. And even along with that, I will be trying to provide you some information about the important tricks and concepts too. Okay. So firstly, let's talk about it, that what are these topics which you should try to cover up and you should not miss. So the first one I would like to say, to understand the quantum mechanics in a better way. And it's not just a topic from where you will be expecting the questions in the exam, but it's something, if it will be clear to you, you will not have any difficulty in understanding rest of the things. And that's why it's important for you to prepare. That is the basics. Okay, now what is there in the basic portion which you have to cover up and which is important for you to cover up, so that you will be able to solve most of the questions and you will be able to work on most of the questions and further advanced topics and advanced parameters. So for that, you need to cover up the basic information, which is regarding the Dirac notation, how you will be solving or simplifying anything given to you in the Dirac notation format. Then you can consider the normalization condition. What is the meaning of the normalization condition and what we mean exactly by this word? Okay, and what it tells us. Orthogonality condition. Okay, and if there is a wave function which is normalized, so what is the meaning of that? Okay, how we can check whether any wave function is normalized or not, or orthogonal wave functions and all. So that should be clear. Then the next one is orthonormal. So this is not a separate, like you can say, a topic that based on which you will be getting direct questions all the time. No, it's not necessary, or it's not always this way. But these are the concepts based on which we can have the questions in the exam. And if we know them, even the difficult questions can look like quite easy to us. So that's why it's important for us. Clear? Now, let's talk about the next part here. If we are going to talk about the next part here, that is related to, again, a common topic, but you have to cover up this topic, because then there are great chances that you can have the questions from this section in your upcoming exam. Now, what is that? That is simply the expectation value and the probability part. So you can expect the questions from this section, that is expectation value. Okay. You can have a question in which you have to find the expectation value of energy or any other operator given to you. So how you will be finding it for different type of wave functions given to you, corresponding to which you have to find the expectation value. What are the steps you have to take? What will be the complete process? That should be clear. Okay. Other than that, the common topic which you have to cover up is the probability. Okay. This is important. So this is the second section of preparation, you can say. The first section I have talked about is the basic part you have to cover up. The second section, which is a common general case, and it's not like it's a topic, but it's something based on any other topic or related to any other topic. You can have the questions from these two too. Okay, means this is possible like for you to get the questions in the exam in the combined form with some other topic and these ones. Clear? So it's important for you to cover it up, and you can't skip this part because then you may not be able to tackle or solve those type of questions. So this was the second section. Along with that, I would like to suggest you to do one more thing, that is you should know if you are having the wave function given to you at some time t is equal to 0. Okay, and this is given to you. At the same time, you want to find the wave function at time t is equal to capital T. Then what is the process when this is given? How you will be able to get the wave function at time t is equal to capital T? Now here I am going to tell you that what you have to do. You just have to multiply it with e to the power minus iota e and t upon h cut. Now, depending on the particular state corresponding to which you are going to multiply this term, okay, or with whatever term you are multiplying it, you have to take the energy corresponding to that. So, this is how you will be able to write it. Psi at t is equal to 0, multiply it with e to the power minus iota e and t upon h cut. I hope it's clear. But again, if there is any doubt, you can just mention it. So this was the one thing from where, or like again related to this part, even you can have the questions in the exam. So what I have done here, if I'm having a wave function at time t is equal to 0 given, and I want to find the wave function at some later time t, so I will be just multiplying the terms of this wave function with this parameter, and that's how I'll be able to convert the given wave function in a wave function which will be at some later time t. I hope that's clear, but again, if there is any doubt, just mention it. So this was all about the basic portion. Now we will talk about the main portion from the quantum mechanics section, which you can't miss, and you have to cover up that section too. Now that is system. The first important thing from the quantum mechanics section which you have to cover up is the important systems. Not just one system is there can be many other. So these are the important systems you have to cover up. The first one I would like to suggest you, which you have to cover up and you should know about it, that is the 1D box, 2D box, 3D box. Okay, symmetric, asymmetric case, wave function expression differences will be there, and this is how you will be able to consider it and get it. So this is what you are going to have, important systems and the box related systems you can have there. Okay, you need to prepare the potential expression, wave function expression, energy expression, whatever expressions you are preparing, you should know the corresponding n value which is allowed. For example, n is equal to 0, 1, 2, 3, or n is equal to 1, 2, 3, 4. It can be any value depending on the formula, which formula you are using there and which one you are preferring to consider. Okay, so depending on that, you can have the different n values. For example, if I'm going to talk about the 1D case for a box, so I will be having the potential 1D, okay, you can say 1D box or 1D potential well. So in this case, I'm going to write it this way. It can have the value 0 or infinity. Let's say 0 for x line between 0 to L and infinity otherwise. Then this is, let's say you are going to have the potential. So you will identify with the given expression that, oh, it's a 1D box. Because potential, if you know, just even when they will give you the values for the potential this way, or they will write it in the statement form, you will be able to identify it. Same time, I'm just going to talk about the wave function. So psi n will be what? Root 2 by L. What is this L? You can say 0 to L, so length or the width, that's going to be L, okay, length of the box. Sin n pi x by L. Sin n pi x by L. Again, L is the same thing there. We are going to have, and allowed values of n here are going to start from 1. So 1, 2, 3 and so on to. At the same time, if I'm going to consider the nth state energy, it is going to be n square pi square h square square upon 2m L square. Once again, for this formula, we are going to have the allowed values of n that will start from 1. Clear? So this is how you are going to have all these expressions. If I will talk about the next thing here, what it is actually when you are going to consider the 2D or 3D cases, you need to know one thing. In 2D or 3D cases, you will be having the terms for y and z, like 3D then y and z both, 2D then x and y, okay, and same with the energy terms corresponding to those many dimensions we will have. So what you have to do in this case, let's talk about it. Basically, energy is additive in nature, means just if you are having 2D case like I have written for 1D, you will just be adding one more term in it. 3D, two more terms in it, and then we will start specifying that okay, it is for x, so nx square pi square h square upon 2ml square. At the same time, if I will be writing for y, ny square pi square h square upon 2ml square, I'll just be adding it in this expression. Same with for 3D case, we will be writing nx square pi square h square upon 2ml square plus ny square pi square h square upon 2ml square plus nz square pi square h square upon 2ml square. Again, the nx, ny, nz values will be starting from 1. Now, next thing. If I'm going to talk about the next thing here, that is, it's not necessary that always you will have the L along x, along y, along z. The dimension, for example, the length given to you, okay, like I have mentioned it here, for x is lying between 0 to L. So, it's not necessary that always for x, y and z, same length will be given to you. So it can be 0 to 2L for y, 0 to 3L for z, that's okay. And accordingly, you will be writing the second and third term of energy, and the wave function is multiplicative in nature. So like for 1D case, I have just mentioned one term. For 2D, I will write the another one just by multiplying it with this. And for 3D, I will be writing two more terms just by multiplying with this. Okay, this is how you have to consider it. If there is any doubt you are going to have, you can just mention it here in the comments. I'll be considering that, and if everything is clear, that's great. So we are now going to talk about the next thing here. That is, once you are going to prepare these things, you also need to know the difference between the symmetric and the asymmetric potential well. How symmetric and asymmetric you can consider and you can classify. So 0 to L, it's like 0 from the center, it's like just the positive side it has been taken. At the same time, if I will take x lying between minus L to plus L, minus L if I will take here and 2 plus L, means that is the range, the overall length you will have is 2L. So minus L to plus L. Then it's symmetric potential well case. And the difference in the symmetric and the asymmetric mainly will be in the wave function. Right now, the wave function is having one particular expression. But for the symmetric case, it will have the two values. One as root 2 by L sin n pi x by L. Another one as root 2 by L cos n pi x by L. Quickly, I'm going to tell you that what is the difference and how you can differentiate between them. So for n odd, means odd values of n, you will have the cos in the wave function instead of sine. And for the even values of n, you will have the sine in the wave function instead of cos. When? For the symmetric potential well. One more thing here I would like to tell you, that is, you can memorize it this way, but that for odd values of n, which is 1, 3, 5, 7, okay, you will have cos in the wave function for symmetric potential well, and for 2, 4, 6 like that, even values of n, you will have sine in the wave function. Now, how to memorize it? Odd values, even function, cos is even function, which satisfies the condition f minus x is equal to fx. At the same time, even values, odd function, which satisfies the condition f minus x is equal to minus fx. So that is sine. Sine is the odd function, cos is the even function. Corresponding to even function, odd values of n. Corresponding to odd function, even values of n. For 1D box, for these formulae, n values start from 1. And the rest of the things which you have to prepare, I have already mentioned it here. And that's how, by considering these things, you will be able to solve or simplify any such type of question. I hope it's going to be clear. At the same time, along with the box, you also need to prepare the harmonic oscillator. So whenever you will be preparing the other system, that's going to be harmonic oscillator. You also need to do the same thing there as well. You just need to prepare the wave function, okay, the potential and the energy. So you will get to know about it, that how you will be able to relate the formula easily. And here you have to memorize this part, clear? Now, Again, I would just be introducing the potential of the harmonic oscillator here, half m omega square x square for 1 decays. Its corresponding energy I would like to show you. Reason behind it, you will be able to get that how the n values are gonna vary. So you can see n values here we will have from 0. Okay, it is allowed. But for the box, the n values were starting from where? From 1. Okay, so this is the difference. And if you're going to identify it, it will be quite simple and easy for you to consider. In the wave function of harmonic oscillator, we are going to have the Hermite polynomial present. It's a lengthy expression, and usually we don't get the questions from that section. But still, I would suggest you to prepare that wave function too, so that like if in case anytime they are going to ask that kind of question, you will easily be able to solve it and you will not have to regret like, oh, I didn't prepare the wave function, that's how I am not able to solve it. So you should try to prepare it's just one expression. Okay, now once you're going to consider it, you can even consider one more point here by changing the form of the energy. Means if I'm writing some other expression, I'm going to consider some other value of energy for the energy state, then I can even have the different n values there. Okay, so that's what you need to know. If I'm going to talk about the half harmonic oscillator, what is the meaning of half harmonic or the truncated harmonic oscillator? There the potential will not be same for the complete reason. There you can have this potential for x greater than 0 and infinite for all other cases and all other reasons. Okay, in this case what will happen? For truncated harmonic oscillator also you can have this energy value, but there the n values which you will have to take will be odd n values. Means 1, 3, 5 and so on too. So odd n values when you will consider, that will be giving you the energy expression, same form. Okay, even different formulae can be there, different expressions can be there, and they will be taking the different n values then. But I'm just telling you the easiest way to prepare the energy expression for the truncated or the half harmonic oscillator, and that is you have to take n is equal to odd values 1, 3, 5 and so on too. Okay, that's what you have to consider. So this was something important from this section which you have to cover up. I'm just gonna check out if there is any doubt anybody is gonna have. I'll be trying to consider it then, but I hope it's clear till now. Okay, once this much part we have considered, now let's talk about the next point, which you can't miss and you have to cover up, okay, from the quantum mechanics section. So that is commutator bracket. The next important topic or the concept is commutator bracket. Clear? Now, what is commutator bracket? Let me just give you a quick introduction about it. Just a second. So that's going to be, we show it with the square brackets. For example, this way a comma b, okay, and these brackets are showing the commutator bracket. At the same time, the cap on the terms you can see are representing the operators. So commutator bracket of AB will be AB minus BA. Another thing is, if I'm going to talk about the next thing there, if these two operators commute, okay, means you can simultaneously measure these two operators. So in that case, the commutator bracket of the operators will be equal to 0, which shows that the operators commute. Clear? The commutator bracket of the operators will be equal to 0. It means they commute. At the same time, there are few more concepts and the properties of the commutator bracket which everybody needs to know to solve the questions in easy way and in less time. So you can simply write it this way: A with B plus A with C. Done? This is how you can write it. At the same time, if we will talk about the next thing here, that's going to be A, B, C. It will be C. Here you have to be careful about this thing. It is the left hand side term. It is the right hand side term. And these two have been multiplied together. So always remember, in quantum mechanics, order or the sequence matters a lot. You can't change the order or the sequence just like that, or you can't write the terms anywhere anyway. You have to keep, see, remember it this way, it is just a place for the one operator, not for the two operators, but two are present right now. So what will happen in this case? You have to take one by one outside, okay, the operators. So left one will only go on the left hand side outside, okay, and this is going to give you AC. Then plus sign there, plus that's gonna be, now the C will go out, but on its own side, okay? It will just move towards its own side. So it's gonna give you B and then C. So you just have to solve this commutator bracket, take it like this operator will remain this side only if you are getting a next operator here. So you will write it this side. Same way, if you are getting one operator for this one, you will write it here and that will remain in the right hand side. So this is how you will be able to solve or simplify any such type of questions based on operators and the commutator bracket. So commutator bracket is another very important concept. One more thing here I would like to introduce, that is the fundamental and the most important expressions of are related to the commutator bracket part. Now what is that? For example, the commutator bracket of x with p or just px, if I will write, it's iota h cut. Even if I will just keep it only p, then also iota h cut. P with x, it's gonna be minus iota h cut. Okay, and at the same time x with y, that's gonna be 0. Y with x, that's gonna be 0. These are the standard expressions. You can even memorize them so that you will not have to spend too much time that at that point of time whenever you will have these expressions present somewhere. X with py, that's even equal to 0. Okay, same component when you are having, then it's iota h cut. Then px with py also 0. Done. Now this is what you have to consider. One more thing here I would like to tell you, after the commutator bracket, the next topic you have to prepare is the angular momentum operator. So in the angular momentum, guys, what you have to do? Firstly, you need to prepare the basic, that is L is equal to Lx I cap plus Ly j cap plus Lz k cap. At the same time, you can consider the further things. For example, if you are gonna operate L operator on some state having the principal quantum number, orbital quantum number, and the magnetic quantum number given to you for that state. So it will simply be giving you root L into L plus 1 h cut, and there is no change in the NLM values of that state. Same way, if you will operate the Lz on some state, then what will happen? Then you will be able to consider mh cut and NLM. Okay, this is how you will take it. Other than that, if I'm going to talk about the next thing here, what it will be, it is simply going to be, there are raising and the lowering operators. Raising operator is simply Lx plus iota Ly. And when you will be preparing the harmonic oscillator topic, at the same time, you will also be getting to know about the raising and lowering operators or ladder operators, okay, which are A and A dagger. So that's how, even by preparing some concepts related to them, you will be able to make your calculation, the process of solving questions quite easy. So I would suggest you to even cover up that part there. Now L positive and L negative, both the operators we are going to have. Simply for that, you have to consider it this way: Lx minus iota Ly for L negative, L positive Lx plus iota Ly. This is what you will have. Okay. Now, once you're gonna cover up this part, now what you have to do next, you can go for the WKB approximation method. Even from the Born approximation, you can expect the questions. From this section, the scattering part based questions can be there. Okay, so I would suggest you to at least check out these things too, okay, so that if you will have any questions from these sections, you will easily be able to solve them. Now, this was the major portion which we have considered till now, okay, and from this section you will find like most of the questions of quantum mechanics you will have in the exam will be from these topics, the concepts we have talked about. Even if you will prepare them in depth and detail, you will be finding you are going to solve, or you will be able to solve any such type of question quite simply and easily. The concepts are these many, means if you will prepare them in detail, and after that you will be finding the subject quite simple, easy. Okay, variational method is there. If you want, you can include that in the topics. Okay, and if all this you're gonna prepare, you will find like, oh, the things are quite simple and easy, and this is the major section which we have talked about here. So we are just going to keep it this much right now in the session, guys. I hope each and everything is clear. So this was a quick session, but again, it's going to be informative, and I hope it's going to provide you a great idea about the type of preparation you have to do for your upcoming exam and what are the topics you have to cover up on the preference basis and on the priority basis. I hope it is going to be helpful this way. Now, guys, let's keep it this much. Also in the session, like in the starting, I have shared the information and the updates regarding the latest offer which is going on. the new batch course which is going to start. Like today it's starting, so if you don't want to miss it, you can take the subscription and start your preparation under the guidance of top educators. At the same time, this is going to be the new update regarding the free unit wise PYQ test. If you don't want to miss them, you can even check them out in the learning app. If you want to grab this offer and you want to get the 10% discount in the total subscription amount too, then you can take the Unacademy subscription, because the offer is just valid till 11th May, means till today. And by using and by applying the referral code, that is Anjali A Live, as it has been mentioned here on the screen, you will be able to get the 10% discount in the total subscription amount, and you will be able to grab the mega offer. Even the difference between the Plus and the Iconic subscription I have shown you on the screen. So you can just quickly go through all these points and you will get to know that which one you are going to find more beneficial for you. And in these courses which are starting by the top educators on Unacademy, you will be able to do the best preparation with the help of these courses. You will be able to cover up many important concepts, points, and many important tricks you will get to know about. So if you think you want to get the guidance, and with these revision courses, the new batch which is starting, you will be able to cover up many important things in very less time. So let's keep it this much right now in this session, guys. Thank you so much everyone for joining this session and for watching it till the end. Thank you.